All right, so on today's episode, we had Roger Krulak, who is the founder and president of Fullstack Modular. Was there anything you liked about this episode?
Yeah, I thought it was a great episode. And we actually got into some engineering concepts as it relates to modular construction, which I didn't think we were going to do. But what's interesting from Fullstack Modular, they create modular buildings mid to high rise, 10, 20 stories. I think they had one that was 20 stories tall. And when these well, I don't want to give it all away, but we did get into some braced frames and some engineering aspects. So that was some of the aspects that was interesting. One other thing that I found interesting about Roger and what they're doing with the modular construction is how it, obviously enhancing the world around us, but how they're impacting the cost of housing and how constructing in a modular environment helps with the workforce, right? We have some concerns with the workforce right now, finding help and keeping help and mental health of the workforce, of the laborers. And so having this type of work where you're in a stable environment, right? Like you're out of the weather, you go to the same place every day. So those are some of the benefits. Again, I don't want to get too far ahead of ourselves, but it was quite interesting to me, not necessarily the type of thing we talk about every week on Enhance, but we
live in a modular home too. That's a fascinating thing to add into that.
That's a connection point. I mean, the Fullstack doesn't necessarily focus on single family. I did find that out, but yeah, we live in a modular home. So
so they build it in one place and then they ship it to another place and then they put it together.
Yeah, and then somebody puts it together on site. So if you can imagine a 10-story building and they stack these up.
Wow.
In modules, boxes, if you will.
But, that's why it's called modular.
Yeah, and you'll find out there's a reason why it's called full stack. So, which I don't want to give it all away. So with that,
you have to listen to the episode.
Yeah, you gotta go listen to the whole thing. My name's Andy Richardson, and this is the Enhance AEC podcast, and this is Madeline, our producer. I've been doing this 27 years with structural engineering, and I'm still learning so much about the industry. Come along with us in this episode and learn the why of AEC professionals, and also you might learn your why as well. Let's jump to the intro.
Welcome to Enhance, an AEC podcast, where we learn the why behind AEC professionals so that you can learn your why.
Yeah, Roger, thanks for joining us on the Enhance podcast today.
Thank you so much, Andy. Thanks for inviting me.
And I like to open it up with just a fun question. So you're in the modular business, and if you weren't in modular construction, but you still had to use modules to have a business, what would you do, and what would you construct, like maybe a toy or other area?
Look, the idea of modular construction, although I'm not a huge fan of the word, is that you take componentry, assemblies and sub-assemblies, and you combine them in order to create something that's useful in one way or another. And what we do, which is sort of fully volumetric modular manufacturing for mid to high-rise buildings, is that we are creating components made up of assemblies and sub-assemblies to create the whole building, its structural systems, its mechanical and its electrical and its plumbing systems. So that is the attempt of the industry to embrace industrialization. And to be fair, everybody else does industrialization. Even all the pieces that go into the building are industrial manufactured. I mean, switch gear and even the tools that you use to put it together. But for some reason, the final assembly, for lack of a better term, has not gotten there yet. But to answer your question about what I would do if I was going to modularize something else. Well, I'm a bit of a cook. I think that there's an opportunity to take a whole bunch of, sub-assembly pieces, and some people have done it, and create easier to make high quality healthful cooking. And people like Blue Apron have done it and that kind of stuff. But I'm like, there's probably, you can even dig deeper into it. So like, take one of these and one of these. And I don't know if it would work or not. I mean, they tried to do it years ago and they had to add back sort of, acts that you don't even need just so that people thought that it was homemade. It's just a long conversation. But anyhow, I would probably do something in that world. And I think also transportation has some opportunity for modularity, I think.
Yeah. Okay. And awesome. Well, yeah, thanks for entertaining the question. It's just a fun way to maybe start the conversation. But so you're a bit of a cook, you said?
Very much so, yeah.
Yeah.
My
What's your
son's a
favorite?
chef. I am advocation of a cook. So,
What's your favorite dish that you like to wow people with?
I mean, I don't know if I can answer this specific question, but basically, I particularly like, Italian cooking and Northern African cooking and Persian cooking, that part of the world. So that's where I focus. But I like to cook all kinds of things.
Yeah. Awesome. Well, I can't wait to try out some of your
There we go.
cooking,
Yeah.
and maybe we'll have it in some modular meal in a modular building.
Exactly. That sounds great. Right? That sounds great.
Yeah. Maybe that's a good marketing thing.
Maybe I have been in some hotels now that have robots delivering like coffee and food. Like there might be, you might get to the point where you can actually say, I really feel like some good tzatziki and shabazi salad, but I would also like, roasted Italian chicken, and then the robot will pick up all that stuff like Wonder's trying to do. I don't know, like Wonder's pretty modular, right? So Wonder is a really interesting game plan, which is exactly that. Like I'm taking 50 great recipes and you can order from 4 different restaurants and we'll deliver it to your house. It's pretty crazy.
Yeah, awesome. Well, hey, I mean, you're in an innovative business yourself, and I mean, we're just having some interesting, innovative ideas. But so the modular business, this is an exciting conversation today for me because it looks like an interesting business that you're in. Can you just go ahead and give us a bit of a background on what it is and how you can help the AEC industry with this type of construction?
Sure. How I can attempt to help the AEC industry with this type of construction. It is a big paradigm shift, but I come from a career of development and construction, so I've been around it a long time. I'm notoriously impatient about most everything. And so the idea of watching sort of the development process and the construction process has always caused me to want to pull my hair or scream at somebody. Being in 2000 or so, I moved to New York and things didn't go faster here. They just went slower, cost more money. So I come from the Midwest where things went faster than they do here, and they cost less money. So I got here and I was like, there's just got to be a better way. The volatility was bad, the predictability was bad. Forgetting the sort of public process. And I'm like, the world, as I just said, the world manufactures pretty much everything. Why are we not doing that? And that's sort of where the journey started for me. Although to be fair, I had a grandfather who did modular multifamilies in the 70s in a thing called Project Breakthrough, which is got an interesting book if you ever want to read about concrete modular assisted living facilities that were built by the government for a long time. Anyway, so I've been around it in my life. I'm ridiculously impatient. I don't like the way construction is disintegrated, and figured we could probably learn something from every other industry in the world and figure out a way to systematize the process in a way that is more efficient and more productive.
So yeah, I'm actually interested in the Project Breakthrough. What was the genesis of that project. And
so what happened was,
grandfather.
I can't remember which administration started it. There's been a bunch of articles and a couple of books that have come out recently, and the U.S. government decided that they needed to find a way to build, assisted living facilities, and they put on a competition, and they basically put out an RFQ and ended up choosing 3 companies across the country to build very similar products, which were concrete modular buildings. And the concrete modular buildings contained this incredible piece, because it was long before CAD and long before 3-dimensional drawings and long before any of the things that make these things a lot easier. They created this guy named Tom Dillon created what he called the heart module, and what he did was he took all of the electrical, mechanical, and plumbing distribution and put it into the concrete slab of the floor, and then aligned everything perfectly. And then the other things were simple, sort of tilt up concrete precast components, attached to the heart module. And then, because it's concrete and not monolithic, there were all these attachment mechanisms for steel and stuff, which were its limitations. But it was in the 70s, and it worked really well through Jimmy Carter. And then when the next president came in, he just killed the whole program. But I'd say 90% of those units are still in use and operating today. So they're pretty incredible and pretty forward thinking.
The idea of the heart module, is that something that you
Have
that
embraced.
resonates with you and still you utilize in your business?
Yeah, I mean, we're a little bit different. We use almost no concrete, and it's because I don't. It's a little bit harder to make some concrete monolithic. It requires a whole lot of steel and a whole lot of attachments. So we use all steel, and we don't even use a poured concrete floor. But we do very, very specifically concentrate on the idea of being able to connect everything in the building together in a way that is organized and identifiable. So all of the structural, mechanical, electrical, and plumbing pieces have distribution within our mods, so they're all complete, and then all you need to do is to connect them together. So it very much is that comprehensive full stack solution for a building built out of components.
And this is for mid-rise, high-rise buildings. Can you tell us a little bit more about that? I mean, what?
Yeah,
what
I mean,
typically-
we were born in Brooklyn, so we were very focused on density. Density is a way to increase volume of housing, which is a big deal in New York, but it is pretty much everywhere in the United States. So we created a system that was resilient and responsive to the forces that happen in high-rise buildings, both whether the major load is from snow or wind or seismic or whatever. Our system happens to be pretty responsive to all of those things.
Yeah.
So it's very, put it wherever you want. And as you have less foundations and more units, you tend to get a lower cost per unit, because obviously those, especially in New York, foundations are pretty expensive. So if you can go up 20 stories instead of 6, then you're getting a pretty good bonus from a cost perspective.
Yeah, so I'm a structural engineer, and Roger, I don't know if you knew that, but
I didn't, but I like structural engineers. They're like some of my favorite people. So.
that's actually the angle I come from. Is but the Enhanced podcast, I'm interested in the entire AEC industry and learning from different people.
So you want to talk structural? We can talk structural.
Well, I'm interested. A couple of things you mentioned. Obviously, the seismic and wind. I mean, now my ears are perked up, of course, as a structural, but also the foundations as well. What is it about? Because I'm down here in the South, if you can't tell, South Carolina. But what is it about New York that is it this bad soils or just cost of soil?
Well, New York has bad soils, but I mean, usually over an electric line, or you're over a subway, or there's a foundation that was built in 1827 and is so out of square that you're hitting it when you're digging down. I mean, there's 100 different. Sometimes, certainly, the south of Manhattan literally is landfill, so you run into water or rock all the time. But the whole idea of our system was to try to differentiate ourselves by creating a system that is, give us something to sit on. We don't care what it is, and we'll sit on it. And then you don't have to touch anything until we're up to the parapet. So facade on, all of the structural componentries, even if necessary, a brace frame, so sort of above 20 stories in a lower seismic zone, and probably 7 stories or 6 stories in a high seismic like California zone. All the mods carry their own moment. They responsive completely. Wow. Up to 20 stories here in New York or South Carolina, wherever there would be a 20-story building, and so the idea is we can sit on steel, platform, we can sit on a parking garage, we can sit on the ground. It doesn't matter to us. But once we do that, there's no three-dimensional connections required from our mods to some conventionally built something that isn't built the way we build things. So it's pretty easy on a two-dimension plane to create an interface that works for the mods, rather than trying to say pour a concrete core and hope you can connect all of these absolutely perfectly built mods to a concrete core. No matter who pours it, even if they pour it in Chicago, it's still not 1/8 of an inch max tolerance like we are with all of our systems, for example.
It kind of defeats the point of modular if you have to connect to a field-built element.
But almost everyone does that. So that is part of the industry's challenges, because what we're doing it really does require a manufacturing mindset. Even though we're not hitting micron tolerances, we are hitting 1/8 of an inch across all systems. It's visibly small, and that is not what usually happens in construction. They're like, oh, you could drop 3 inches on a concrete slab, and you can miss a pipe by 2 inches, and you could but it doesn't work if it's all one thing. So it's all one thing.
Well, if you add an inch here on this element and another inch over here.
Compound tolerances are a potential problem for sure. And then the other interesting thing about it is, I think as a structural engineer, is that almost always our system is just bolt together in the field. It's just an erector set.
Okay.
So there's no, and then to give you a little more structural engineering, our diaphragm is the roof and not the floor. So that way we can connect the diaphragms together without having to be invasive inside of a fully finished mod.
Okay, awesome. Yeah. Now, some people maybe don't know what a diaphragm is, because we have A, E, and C's listening to this, and hopefully others. But what does that mean, a diaphragm?
Yeah. So our mods are pieces of the building, and just like if you're building a regular steel column building, floor by floor, you have to tie those columns all back to each other so that they act as one system rather than multiple systems, and that structurally, and that way everything moves together rather than moving differentially. And if you need me to explain differentially, I'm happy to do it. But that's, and usually that's, well, I'd say very often that diaphragm is created by building a component of the building, then pouring a monolithic concrete floor. It ties all of those pieces together, or a steel deck that ties all of those pieces together, and then you build the next floor. But that's usually when you're putting the superstructure up prime first, and in our case, you're not. You're putting everything up at the same time. So we decided 15 years ago that, well, if you want to connect those and create monolithic items in a fully finished room, you have to leave a big hole open and you have to tie in, at the floor all over the place, which a lot of people still do, by the way. Like, that makes no sense. It doesn't matter where the diaphragm is. As long as it's floor to floor, it doesn't matter if it's the ceiling or the floor. So we did on the ceiling where you can just walk on top of it and bolt everything together.
Okay.
How's that?
That sounds great. I mean, yeah, you need a job as an engineer.
I've been talking this stuff for a long time. So.
Yeah, nice. Well, one way I explain diaphragm, this is a more like elementary way of explaining it, but I think about these big cups that you get from the fast food, like McDonald's or whatever, Hardee's, pick your fast food, and these huge cups, and when you don't have a lid on it, right, it's like flimsy.
Yeah.
And then you put that lid on the top, and now it won't go everywhere, right? It kind of creates some rigidity. I mean, it's a simplified example, but it creates some rigidity for that whole cup, and now you don't spill Coke all over while you're driving down the road.
That's true. I think a lot about our modularity and the idea of that if you had a bunch of mods and you didn't have a diaphragm, you'd have one mod up here, one down here, and then every time you moved in the building, it would feel a little bit like anyway. So that it's very much that too. So.
But if you ever have to explain that to one of your customers, maybe you can.
I appreciate it. They don't care about the diaphragm, but anyway.
They just want it built.
They're like, as long as the building stands up and it costs less, we're good. So anyway.
Yeah. But I am interested also about I didn't want to make it all structural, but structure is a big deal. I mean, you're going, what's the tallest you've gone, by the way?
33 stories.
33 stories. Where was that one?
In Brooklyn. Yeah. Brooklyn,
okay. But you're going 33 stories, you have to have a lateral system. So structural is a big deal. And you said it comes with its own structural system built in for lateral and gravity.
Correct.
So, and is that normally a braced frame you mentioned, or what?
Well, it's sort of in on the East Coast of the United States where there's nothing high seismic, it's the mods, just the mods, up to 20-ish stories. And then above that, you would need a brace frame. But the brace frame, again, is manufactured as part of our system. It's bolt together. I don't want to get too into the other stuff because it's complicated, but it's bolt together.
It's an exoskeleton of sorts that is visible from the outside, but it's bolted as a part of the module.
Basically, just think of it as interstitial. If you have 10 mods wide, and you're doing a double loaded corridor, you'd have two brace frames in between two sets of mods, and then probably something in the opposite direction. So two in the X, one in the Y, up and down the building, just bolted together as the mods come together down. Then you'll have a brace frame in between, and you just bolt it together as it's going up. It's in situ. Yeah. So, yeah.
Got it. Now, that sounds awesome. I mean, you've done a lot of work to get into that point, but that begs the question of which is cost, right? Mm-hmm. So I would imagine there's a significant cost of that, or is this can
pretty
people
cost
afford
effective? This? Pretty cost effective. It's interesting. So we use about 25% less steel than a conventional steel and concrete building. So. It actually is quite, even though there's redundancy on a weight perspective, it's quite a bit less. So the foundations can be lighter. There's a whole bunch of other value propositions associated with it.
And what are the primary types of buildings? Is it mostly like multifamily or?
Yeah, I mean, if you think about hotels, student housing, and multifamily, that's the majority of what we do. It's also relatively applicable to, say, hospital rooms, like not the whole hospital, but the hospital rooms. Anything that could be unitary that's not wider than, that's normally not like, there can be exceptions in the building, but if it's normally not wider than 14 foot wide, this is relatively applicable.
Yeah.
So if you have an apartment that's a, two bedroom, and you have a bedroom on one side, a bedroom on the other, and a living space in the middle one could be 14, the other two could be 10, and that could be a two bedroom. But you don't really want this. You can't really make anything wider than 16 feet because you can't transport it anywhere, and 16 feet is a extra wide load, so you need the policeman, and it just becomes very expensive. But if you keep it 14 and under, it tends to work pretty well, at least here in the U.S.
So multifamily apartment, any single family type stuff or townhome?
No, it's really our system. I mean, we have an ADU because they're all over everything all the time. We have an ADU that we can build that we think is pretty well designed, but it's not our main focus.
Yeah, this is the deal. This is the focus. Okay, that makes sense. And then how does the foundation work? I mean, is that just by others or?
I mean, so we're involved in the whole process, but it depends on what kind of foundation it is. I mean, we're talking to somebody right now about building on top of a 5-story building. You have to figure out how to transfer the loads to where it belongs, et cetera, and you have to work with the engineer that designed it or an engineer that can do the analysis to do it. But normally it's either a concrete or a steel foundation of some sort, and then we have a designed embed system that goes on those foundations, and that's the interface. And those embed systems have pins, and those pins are XYZ aligned with the zero datum of our building, and then you just stack them on. And if you get that right, then stacking it up is a piece of cake. And if you get it wrong, you have to make up that difference somewhere, which we don't really let anybody do, because if they don't get it, if it's not to quote Marissa Tomei, if it's not dead on balls accurate, we're not moving forwards.
Right. Okay. That makes sense. I mean, once if you're at the 8th, you can't really afford to, you're never really going to catch up or make that up over 20 stories if it's off.
We can do it. We have methodology to do it. The system has adjustments that you can do in order to pick that stuff up. It's a lot easier just to get it right. But we can, we can shim, we can pry, we can shim some. We have about a 1/2 inch shimming capacity in any direction. So we do have some ability to adjust, and if it's a big bust, as a structural engineer, like you're not going to do that in 1 floor. You'll do it in 4 floors, for example. But we don't want to start there.
So your grandfather with Project Breakthrough, was that really what gave you the idea for all of this, or was there something else that made you think we need to get this going?
I mean, I was always excited about what he did. I just don't. I've been in construction and development for most of my life, except for when I was cooking for a little while, and I just don't. It's just not smooth. The process isn't smooth. I call it disintegrated all the time because it is disintegrated, and so to me, it's like it doesn't make sense that like 13.5% of the world economy is like in the most disintegrated, least productive, industry in the world. It makes no sense. So to me, that's a rub that I'm like, hey, can't we do something better than this?
Yeah. What's the biggest headache that you see when you look around at this?
Yeah, I mean,
disintegrated concept.
Yeah. The biggest headache to think about doing something differently is that what we do, sort of the let's call it design, build, insert industrialization, is that it requires a big paradigm shift for all stakeholders. So architect has a different role, developer has a different role, contractor has a different role, and we're doing, somewhere between 70 and 85% of the work in a factory. So it changes the whole paradigm, and everybody is always excited about it. And then when they get nervous, they go back to what they're very much used to, and that completely destroys the value of the proposition. And so we are moving towards vertically integrating and becoming part of the development team. Not the only part of the development, but the development team, so that we can drive the efficiencies that are needed in order to get value out of that. So that's been frustrating because it works, but everybody has to get on board.
What do you mean by that? Everybody, like
Yeah, I mean, all the people I mentioned, the developer has to get on board, the bank has to get on board, the general contractor has to get on board. Communities are not too much I mean, there are some rubs, in the authorities having jurisdiction, et cetera, but not huge rubs. But mostly it's getting that whole team to act as a team driving towards the best solution that you can have for what you're doing. And it is hard for people to shift.
And what is the holdup with these different parties, in your opinion?
Yeah, I mean, okay. So from an architect's perspective, I would just take each one of them. From an architect's perspective, they have to embrace a system, right? So they're using a system that has parameters associated with it, and they have to embrace that system and share agency with the fact that you have a system that has things that are valuable and work well, and things that are less valuable and don't work well based on the use of that system. Does that make sense?
It does.
Okay.
I mean, you have inherent characteristics of this system, just like any system.
Totally.
And you do have to live by those characteristics, basically.
Totally. But, if you tell them that, I want to use, micro laminated beams, they're going to be like, and spacing has to be every 8 foot on center. They're not going to think about it, right? But if I tell them my mod needs these things in order to be effective, somehow it's like, why? Because it's everything, right? It's so that's the first thing. The second thing is the general contractor. So the general contractor, and there's great general contractors out of them. Many of them have done modular projects before. But the reality is that their scope is severely diminished, and the value opportunity to the end user, call it the developer, is contingent on Fullstack or whatever modular manufacturer it is building efficiently, time efficiently, cost efficiently, and appropriately. And then the general contractor has to take those built mods and install them on site in place, and do that in a way that is also time and cost effective. And that requires them to really understand the system that the modular manufacturer is using. And there's really, honestly, nobody who does that well yet. I mean, they're trying. There's a bunch of companies who have their own modular general contractors with their own modular divisions. Some of them are, I know them and they're very smart, but that's a big issue. And the reality is every system at this point is different, right? Every modular system is different in some way or another. So that's that. And then the developers are being asked to put, and the banks are being asked to put up a bunch of money up front, because we buy all the materials, we buy everything in a building, almost. There are exceptions, but most everything in a building. And we have to pay for that. And oftentimes, standard construction loans and draws rely on two things. They rely on sort of a bell curve of cost. It starts out really slow, and then it gets heavy, and then it tapers off. And then everything is usually on site when it gets billed for, unless it's like, long lead items or something like that. And in our situation, the mods are in the factory where they're getting built and progressing, and they don't necessarily land on site. And so then the lenders and the developers don't know how to secure the value of the building that's being built. So they get nervous. And then they go back to what they're always used to, and they don't know what to do. And they're like, oh, just deliver me the mods. I'm buying $100 million building from you. You spend $85 million, and when it gets to the site, we'll pay you. I mean, obviously that's not happening, but that's how the industry thinks. And that's how construction draws work, and that's how, and so all of those things require a shift in order to be effective. And it's a slug, right? It's a slug.
Yeah. And don't forget those dang engineers, right? You got those to deal with.
That's the least. You don't want to get me started, but for the most part, I mean, and I'm not going to, one day we could talk offline about how I rank engineers, like structural engineers, mechanical engineers, plumbing engineers. Anyway, but doing what I do I incredibly respect, the engineering side of it.
Yeah.
I have different opinions about types of engineering because of the kinds of buildings we're building, but that's just because it's my world that I live in. But for the most part, have very few problems with engineers unless they don't engineer, which has been in my life an experience that happens often, which is they want to take what they've done before and repackage it and put it in another building. That I don't like very much, but that's not an engineering problem. It's a personality problem or a business model that is pretty ineffective. But anyhow.
Well, they're trying to modularize their engineering.
No,
right?
but yes, totally. But the reality is if you have a system in our buildings that works, you can really repeat it over and over again. There's no reason to change it. But if you want to take something square peg, round hole, that's probably not going to work so well.
Right. And I appreciate you letting me rib you a little bit about that. The contractors that you bring in. So you guys are delivering these to the site, and they are installing it. You're not installing it yourself.
Correct.
There's a general
That's what we do at this point.
Yeah. Okay. So that's really. It sounds like a big impediment right now. But what are you doing to help get over that impediment?
Yeah, we're trying to shift the paradigm whereby we are actually contracting We're either contracting the general contractor or we're contracting alongside the general contractor so that we can help deliver what it is that, what the promise of modular is. That's really what we're doing to do that. We're just changing the relationship a little bit. So.
Yeah. Okay. So you're making it, you're expediting it. Yeah, that makes sense.
Well, just put it this way. If I'm building 85% of the building components all together and then delivering it to the site, and the general contractor is set up to accept and install those mods, and they're not willing to sort of figure out how much less work there actually is on site, and we have to deliver a building in a year, and we're finishing in 6 months. It shouldn't take 6 months to do 15% of the work, but a lot of times they don't know how to figure out what that all is, and then the stress sort of comes back on the modular manufacturing to say, oh no, we meet it, twice as fast because we don't know what to do until that happens. And it's just a big shift, it's a big shift. Yeah.
So what's the biggest selling point for a buyer, a developer, or an owner to using modular versus other, quote, traditional methods?
It has the ability to increase velocity, which is a huge problem in the United States, anywhere you look. It is high quality. It is more inspected than anything that's done conventionally. And depending on the market, it's often lower cost. Not everywhere is it lower cost, but it's often lower cost.
Mm-hmm. So, yeah, but you get, even if it was the same cost, or even a little more, you still have that velocity that is a huge benefit. The simultaneous.
Yeah. The other thing worth knowing and thinking about is like, what's so good about modular? We do a lot of work to create industrialization, but if you really look at the bottom line stuff, you do have speed, and in a factory, labor is roughly 3 times more productive than on a job site. It's roughly 3 times more productive.
And why is that?
It's industrial engineering. It's really simple. You have repetitive work that is being done in an organized, ergonomic fashion over and over again, where you improve every time. If you're in a conventional job, you send somebody to one job and they build a hospital today, and next week they build an apartment building, and then next week and you're not getting any velocity from that, and they're working with a whole different group of trades, and they're working with a whole different product, and it doesn't really, in our case, you're getting the repetitiveness and, sort of industrialization 101, proves over and over again that you get productivity. So the opportunity for the cost savings is make a building that has enough repetitiveness so that you can increase velocity and use less labor. The materials, we have less waste, significantly, but you still use this materials basically cost the same thing.
And what materials are you using for the construction of these? Like, is it wood, steel?
Paper mache. Sorry. So it's it's very light. It's the Buckminster Fuller idea that if you make the volume big enough, it'll just float around, and you don't have to worry about anchoring it to anything other than a tether. But we use HSS. It's our chassis is an HSS chassis. We use a cementitious board floor and roof deck, and then interstitial CFS joists. And at this point, often, drywall on the walls, although I am itching for a solution for that.
Yeah, awesome. So structural steel columns and framing, you got some cementitious board, and then the CFS cold form steel.
Yep.
So awesome. And you said you're itching for a solution for the drywall, which brings me to a question of what's the next big thing for Fullstack for innovation? Is it the drywall, or are there other things that you're looking at that are going to be innovation?
If you think about the tasks that happen in a typical construction site, the interesting thing about it is if you apply drywall, tape and finish it, it's 3 to 4 coats processes. Then if you paint it and you do, 2 to 3 coats, and each one of those takes 6 hours, I can build a whole other mod by the time I install the drywall and finish it. So the idea of eliminating that, if you look at where the line balancing is, that's the biggest issue. Everything else is pretty simple. So yeah, that's a big problem to solve, and I'm not the only one. There's people all over the world looking for a solution. The mag oxide board community manufacturing worldwide has been playing around with stuff because it is fire resistant, bug resistant, and everything. I'm not sure it's that much easier to finish, but it is way more resilient, right? Like in drywall, if you bump into it the wrong way, it cracks. Mag oxide board doesn't. But there is a solution out there, and it would rapidly increase our productivity for sure.
Yeah, so maybe we got some innovators out there that can solve that problem for you.
If you're listening and you have a solution, don't forget my number. Call me.
Awesome. Anything else that you are working on that's interesting? I mean, you obviously probably have some IP that you can't share, but what's the next big thing for?
We have lots of IP. Look, I mean, the one good thing about building in a factory is you see what's happening every day and you see what can be better. So, what we're doing today is vastly different from what we do when we started 15 years ago. And we are always looking for ways to tweak that performance. And then, we're always looking at ways to say, like, can we expand our marketplace? So could we build a low-rise solution that's not quite as complicated as our structural system that, goes 4 or 5 stories? So that's the rest of the country, not the big urban environments, for example. So those are things we're always interested in doing, but we are always tweaking. I could give you my structural engineer's list of things that have to get better if you wanted, but my structural engineer would be unhappy if I sort of gave you the whole list. But it works incredibly well. But there's always room for improvement.
Yeah, awesome. Well, Roger, one of the things that we really try to get some information on the Enhanced podcast, because we're all about understanding your why, understanding how people enhance the world around us, which is a different angle on construction, right? But we all should have, in my opinion, we should have a higher purpose for our work. Do you agree with that? And do you have a why? What is your why?
Yeah, I mean, I am astounded at how badly this country is meeting the housing needs, and I am also astounded at how oftentimes the way that we try to meet the housing needs means we're importing low labor country products in order to make that work, instead of being innovative and finding ways to do that and still give people a living wage and produce cost effectively. So my I didn't say this, but we're in the factory where we are countrywide building trade aligned, and what we do is we are an alternative apprentice program for potential construction workers to come into the factory and learn a trade in a way that's atypical from a standard apprentice program. So we are a teaching mechanism. We are creating cost-effective housing, and we are, with Velocity, able to at least help make a dent in the housing needs in affordable through workforce housing, and that's really our focus. That's what we do all day.
Yeah, I mean, those are some significant ventures right there, because I've got some kids that are getting into career age right now, and I can see the pain of the housing, and it's real. I mean, it really is. And the cost of housing, the cost of living, it's not going down. It doesn't seem like. So I'm glad to see there's some people out there with some innovative solutions for some of these problems, and also the teaching and the value that you're putting on the workers, like you're teaching them trades, because mental health in the construction industry is a problem. It's a tough business. And it seems like this modular type of working in a factory, do you think that's going to help with that aspect of things?
So let me answer it this way. It's physically taxing, maybe not quite as taxing, but it's definitely physically taxing. It is a hard day's work. What is different about it is you come to the same place every day with the same people. It's a much more family environment. Everybody knows everybody. Everybody knows who to talk to. Everybody knows where to go to. They know where they park their car. They know. So it does change the dynamic and the relationships within the factory, which I think are significant. And we have people who sort of in their later years walk out of the standard construction trades and come to work in our factory because they just want to go to the same place every day and be useful. And a lot of them are teachers. So we have trade experts in our factory for all of the major trades, and they teach these young apprentices quality work. And it is incredible to see somebody who just did a pre-apprentice program for 6 weeks, after high school, and they walk in and they're, in 3 weeks as productive as you can imagine just by doing that. So it's pretty cool.
Yeah, that does sound awesome. It reminds me of another person we had on here, Andrew Brown. He's into the trades. He teaches and talks about the trades a lot and the benefits of that. So you can check out that podcast too if you would like, and you may even connect with him. But
yeah.
So Roger, I just want to give you an opportunity if there's any topics that I missed that maybe you wanted to touch on today.
I think we've covered a lot. If you're ever in Carson, you want to come see our factory there. We have a factory on the East Coast, which is ramping up as well. So, it's a pretty interesting way. Actually, Mayor Mahone from San Jose came there. He has it on his podcast. He even talked about it in the governor's race conversation the other day. So, we're excited about what we're doing, and we think, and we are looking to expand where it makes sense, and collaborate in doing everything that I just said in as many places as it's needed, which is pretty much everywhere. And so it's going to be a busy time. But I do appreciate the opportunity to speak with you, and I do more than anything appreciate the ability to geek out, because oftentimes they're asking me questions about economics and all this stuff, which I'm happy to answer. But I really do get into the geekiness of our system and how it works.
Yeah, I didn't think we were going to talk about diaphragms today, so that was fun. But I missed part of that though. You said you have one in a factory in both California and Connecticut. What were the cities?
Yep. Yeah.
For those?
Yeah, Hamden, Connecticut, and Los Angeles.
Los Angeles. Okay, awesome. Yeah, if I ever come to that town and or city,
Yeah, let me know.
then I'll come look you up. I've never been to Los Angeles before, so maybe I'll
Well,
come.
it's different than where in South Carolina do you live?
It's called Beaufort. It's near Hilton Head. It's in between
Yeah.
Hilton Head and Charleston. So
Yep. I know where that is.
on the East Coast, we actually have some seismicity over here. By the way,
Yeah.
there's a epicenter of seismicity in Charleston. So,
Interesting.
but yeah, we may have to use some of those brace frames if we ever do
Awesome.
that.
Bring them on. You know, when Charleston wants a 20-story building, you let me know. So.
Yeah, definitely. And if we did, where would people find you for that if they wanted to get a full stack building?
Oh yeah, I mean you can go to our website and just go to info and fullstackmodular.com and play around with some of the stuff we do. You can design your own building if you want, and then for fun, and then you can send us a request at info. It'll give you a link, and we will get back to you.
Okay, so even your website's modular.
Basically.
Now, what's the shortest building? I mean, aside from the ADUs you've done, which is your
we've done stuff that's 4 and 6 stories.
So 4 is about where the economy comes in.
The economy comes in really over 7. So if you can't build it out of wood, sort of 7 and over is where it starts to really kick in. So once you head towards the what they would call high rise everywhere but New York or San Francisco, it's when we tend to be effective.
Okay, awesome. Now today's Thursday, so this weekend's coming up. Are you got any big? You gonna be cooking anything good for the weekend?
Yes, I am going to cook some eggplant bolognese because that was the request of my kids tomorrow. So that's the plan.
Okay.
And my son is a chef at a restaurant in New York, and my wife and our friends are going to his restaurant tonight for dinner. So I'm super excited about that.
Oh, awesome! Well, that sounds really fun. Well, Roger, hey, it was a joy to have you on today. A lot of fun, learned a lot, and hope to connect with you more in the future.
Thank you so much, Andy. I really appreciate the opportunity to speak.
Of course, take care.
Hey everybody, thanks for listening to today's episode of Enhance. And please leave a like, a subscribe, or a follow, and we'll see you next time.